Hello everyone, welcome to this amazing YouTube channel Programming with DPwala. This is Yash. So today we are discussing the problems from the Leetcode Weekly Contest 397. This contest was really very interesting and I can say the problems are really very well balanced, and the last problem, the fourth problem, is really very interesting, and I can say it is very hard because uh, the concepts involved in it and the constraints that they have given, it has played a major role here in this contest. And this question, many people has solved this question using DP and bit masking, and I can think that many people have overcomplicated the problem, and I think most of them that's why not able to solve this problem. And even I can think that this problem is not that much difficult, but it's quite not intuitive to write a backtracking approach during the contest. So let's discuss the simplest way to implement this problem. And uh, I tried to explain it with the help of the backtracking approach. There is no DP and bit masking involved, and it is a very simple approach to solve this problem. And one more thing I will suggest to all the users, that if you try to implement this problem and if you don't know how backtracking works, so you can solve problems such as Sudoku problem or traveling salesman's problem, different kind of problems you can solve which involves a backtracking technique, because this will help you to understand how backtracking works, because this is very important concept as per interview point of view. So let's discuss this problem. So in this problem, we are given an array nums, and which is a permutation of 0 to n minus 1, means n total n numbers. So it is a permutation from 0 to n minus 1, and the score of any permutation of from 0 to n is named as permutation. So here they have given a formula which will calculate the score of each permutation. So the formula is permutation of 0 minus nums of permutation of 1. Permutation absolute difference they are calculating. Then permutation of 1 minus nums of permutation of 2. So here you can see that there is a formula, we can say a catch here is that permutation of I minus nums of permutation of I plus 1. So every time they are subtracting it from the permutation of I minus 1 in the nums array. So this is a thing that can need to be take care. So here what we need to do is that we need to return the permutation which has minimum possible score. So here most of the people able to get a minimum possible score, but they were facing issues in getting a permutation, because here we need to array, we need to give return the array which will give us the minimum score. And there might be a multiple arrays possible, but at last they told us that we need to return the lexicographically smallest one. So here is the case that uh, we need to return the score with the minimum value and the lexicographically smallest permutation. So that's why here many people were not able to return a proper backtracking approach, because finding a minimum score is easy, but getting a proper permutation array is quite not intuitive, or we can say is difficult to write. So here the intuition is that, let's say we are having a array. Here they have given that, you can see that nums array they have given, which consists of 1 0 and 2. So here the possible permutation minimum with the minimum score is 0 1 2. So rather than taking the sample example, I will take my own example and try to tell the approach. See here, let's say we are having a array given as 1 0 4 3 and 2. Let's say this is the nums array that is given to us, right? So here, what we need to do, we need to generate a permutation which will give us the minimum score. right? And that permutation should be lexicographically smallest. So the first observation here is that here the smallest, as they have mentioned here, is that the elements are present from 0 to n minus 1, means 0 is also present. So the best possible way to start the permutation is to pick the first element 0, because this is the best way to pick, because every time 0 is the first element every time. So fix this position. Now when are at ith index, this is the 0th index, right? So when we fixed, or we can say put 0 in the permutation array, and this is the best way to start our permutation array. So what is the score here is that the formula they have given, permutation of I. So the permutation of 0 is nothing but 0 minus nums of permutation of I plus 1. So here you can see that no element is present here, right? So we need to check for the more elements, right? So here the catch is that you are thinking that what second element we need to choose. So as you can see that here the constraints are from 2 to 14. So 2 to the power 14 combinations, right? So you need to check for each and every element, remaining element that is present in the array, which is the best possible one. So the combination that can be possible is that 0, you can put 1, you can put 0 comma 2, you can check for 0 comma 3, you can check for 0 comma 4. Due to constraints only we are checking for each combination, because we don't know that which one will give us the minimum value, right? So we are starting with the very smallest value which is next to 0. So here you can see that 1 is next to 0, right? So we'll be checking for 1, the next element, putting 1 as the next element and checking that whether we are getting the minimum value, and whether that permutation is that whether that particular value leads to the successful permutation that we want, right? So here let's say if we are having an element as 1, second element as 1, right? Let's say what is the score now. So now for 0, so permutation of 0 is nothing but 0 minus nums of permutation of I plus 1. So nums of permutation of 0. So nums of what is permutation of 1? Permutation of 1 is nothing but 1. And what is nums of 1? Nums of 1 is nothing but 0. Correct? So its score is 0 only. Similarly, let's say we choose 1. And this is the best way. Then we'll be checking for next element, that is 2. Calculating the score again and checking that whether it is a minimum possible one. Then next element. Just I am explaining it. We don't know that whether 2 is possible or not. But at every point, we need to check for the all the remaining elements which are there to side of 0. Here, after 0, the elements that are left behind in array is 1, 2, 3, 4. We'll be checking for each element whether it is possible or not. And every time we are calculating for this 1 as well, 2 as well, 3 as well, and 4 as well. And every time we'll be backtracking. The reason behind backtracking is that we don't know that which one will be give us the minimum possible answer, right? So every time after calculating for the particular value, we need to backtrack. We need to move to check for the next particular element that can be keep at that particular position and check the value. So this is the overall intuition behind it. I can say that this is the uh, way to think in terms of backtracking. When I will explain my code, you will definitely understand what I'm trying to say. Because dry running over test case is easy in this problem, but implementation is quite difficult. So when you see the code, you will definitely understand. So the biggest intuition is that we need to start with 0, because this is the best possible way to start our permutation, because that is the only permutation which will give us the minimum score, which will be starting with 0. And the remaining next element, we don't know which one we are choosing. So let's discuss the code. So here what I have done, I have created a vector result. This result will be storing our final answer, and minimum sum is storing our minimum possible sum for that particular permutation. And here in my find permutation function that they have given, I have created a visited vector. Visited vector will be storing the uh, check for whether that particular index, or we can say that particular element, is visited or not. And this permutation will we are using for storing our elements, and every time we are using it for backtracking. We are popping element, we are pushing element inside this only. And at the start, as I have mentioned, that the best possible way to start our permutation is to put 0 at the start. So here I have put 0, and I marked the 0 value as 1 because it is present in our permutation. And after that, I have called the backtracking function, which will be having nums, the starting point that is 0, visited array and permutation array. So here, what is our base condition? So whenever you write any recursive solution, as backtracking is nothing but a recursion, so we need to have a base condition to break. So when we need to break, as we know that when our current sum we are calculating in our permutation, let's say this part we have taken 1 comma 0, right? We will calculate the some current sum for this permutation by the formula that they have given. This formula that they have given, by this we have calculated the current sum. If the particular current sum is greater than the minimum sum that we have calculated earlier, means that that current sum is not a valid one. Means we don't need to further check for the remaining element, because ultimately this will be giving us the maximum answer, right? And we want the minimum value, so we will not checking further for that particular permutation. So we'll be returning from that. This is the base condition. And at last, if our permutation vector size is equal to the our fine main nums array size, means we get our permutation. So we'll be calculating the current sum. As here you can see that the last value score is permutation of n minus 1. Here I have done permutation of dot size minus 1, which is n minus 1, and nums of permutation of 0. So this formula I have applied because this is we need to calculate the score for the last element as well, and we'll be checking that whether the current sum for that, means the particular sum for that all the permutation that we have calculated using formula, is less than that minimum sum or not. If it is less than minimum sum, means that current sum is one of the possible value answer we are looking for, and we'll be storing the this permutation in our result. Means that can be a possible answer. We don't know whether it is the final answer, but as I have mentioned that for this 012, the permutation may be 102 as well, but we need to return the lexicographically smallest one. So we need to check for the different things as well. So that's why we'll be checking here. And every time, this is the base condition and this is the last condition that I have handled. And every time what we need to do, we need to traverse to the visited array, we can say to the entire 0 to n, and what we 0 to n minus 1. So what we need to do, we need to check for that particular value, that whether that particular value is visited or not. If it is not visited, means we can put that particular value at that position. Means I am trying to say that here you can see that after 0 we can put 1, we can put 2, we can put 3, we can put 4. So here we are doing the same thing. If that particular value is not in the permutation vector, means that is not visited, so we can try for that as well. So here I am doing the same thing. I have marked that particular index as visited. I push that particular index, we can say element in that permutation vector, and I have called the backtracking function. So here the backtracking function, here our current sum changes. The reason is that as we have added the element, we need to add the current score as well. So this will be calculating the current score. I am using this particular formula only, nothing different I am using, doing this. So I have calculated the backtracking function. It will do the same thing. And as I have mentioned that we need to check for the next combination as well. So what we will do, we need to remove one, means here what I have done, here I have backtracking. Let's say we have added 0 1 after 0, right? So you have calculated some value for that and you get answer as well, let's assume that. But we don't know that whether by adding 2 we'll be getting the minimum value or not. It's pretty simple here that it will not give, but let's assume for the bigger test cases. So we need to pop it one, and we need to check for the current element, that is two. Similarly, we'll trying for the all the combination, which will be giving whichever is giving us the minimum answer, we'll be choosing that. So this we have popped the one, we have marked it as unvisited. So we are trying the all the combination, permutation and combination, and we are backtracking it. So this thing I have done, and this is the very good thing that we are maintaining a visited array will be, and it is necessary here because we need to track the whether that particular value is, or we can say number is present in that permutation or not. If it is not, then we can add that, we can try that number. In this manner, I have tried it. It is not a easy one, I can say, but writing a permutation, we can say writing a backtracking solution and coming up with this approach is quite difficult for me as well. But uh, I tried to explain it very in a simpler manner, because most of the people have solved this using dynamic programming and bit masking, and I can say that that thing is not quite intuitive. You require a lot of practice to think in terms of bit masking, because you need to practice a lot to solve the bit mask problem. As there were lot many problems. If you can practice, you can definitely able to solve this using that as well. But I think that for this particular problem, as constraints are good enough and they are supporting us, so why not to apply backtracking, right? So I tried to explain it with the help of backtracking, and hope you learned something new today, because this problem is really very interesting, and I can say that this can be a good problem to ask in interview as well. So if you got the approach behind it, so always try to see the constraints properly. Uh, Try to think with the help of pen and paper, and try to check for the condition that I have here done, that whether this value is possible or not in terms of backtracking. Because every time whenever there a constraints are very small and there is a possibility that you can try all the permutation, you can think in terms of recursive backtracking. So this is the approach for this problem, and hope you got the approach. Hope you watch this video till this point. Please don't forget to like, share, and subscribe to my YouTube channel, and keep supporting me. And I will try to do the problem analysis of all lead code, code 7, code for this contest analysis. Thank you. Happy coding.